This is from our formal homework. It's question 2 and it's an induction question. So it says use the method of induction to prove that 13 to the power of 2n minus 1 is divisible by 14 for all integers where n is greater than or equal to 1. So I'm just going to let u of n equal that function, 13 to the 2n minus 1. Sorry, that's not right. 13 to the 2n, yeah, minus 1, like that. And then I'm going to let n equals 1. That means u of 1 equals 13 squared. Take away 1. 13 squared is 169. Take away 1 is 168. And that is divisible by 14. So therefore we are true for 1. Next, I'm going to assume that this statement is true for n equals k. So that is u of k equals 13 2k minus 1. We are going to assume that that divides by 14 or is divisible by 14. And then I'm going to look at u to the k plus 1. So u to the k plus 1, what would that be? That would be 13 upon 2. Instead of writing k here, it's going to be k plus 1. Take away 1. If I do this one, take away this one, let's see what we end up with here. I think I'll move this up a bit. So what am I doing? I'm doing u to the k plus 1, take away u to the k. That will be 13 to the 2k plus 2, take away 1. And I'm subtracting then u to the k. 13 to the 2k minus 1. And let's try and kind of tidy this up a little bit. And I get 13 to the 2k plus 2. I have a minus 1 minus minus 1 there, so those ones are just going to disappear. 13 to the 2k. Again, we'll move up a bit. Hopefully you can see that. There's a common factor there of, what, 13 squared, is it? So if you take out a 13 squared, there's not a common factor of 13 squared, there's a common factor of 13 to the 2k. Take out 13 squared in the front. 13 to the 2k. Take away 1 upon 13 to the 2k. So, excuse me. Hopefully you can see, say I multiply this by this, you add the two powers, so you get 13 to the 2k plus 2, so that's why that equals that. This is just times 1, so that's all okay. Now I have a 13 to the 2k, which is my common factor. And then I have inside the bracket, if I put the e's now inside the bracket, I'm going to have 13 squared, take away 1. That gives me 13 to the 2k upon 168. 168 is divisible by 14. If I multiply 168 by a whole number, which this has to be, then that's going to be divisible by 14. So what do I have up here? Again, we need to think about this. This is divisible by 14. So if I subtract this from this, and the difference is divisible by 14, then this must be divisible by 14 as well. So if, I guess I've pretty much proven it. That's divisible by 14, that's the difference. So that means u to the k plus 1 is divisible by 14. So we're pretty much there. We just need a wee statement at the end, kind of summing everything up. Therefore, if true for u to the k and u to the k plus 1 is divisible by 14, and if true for a small u, so that was u of 1, therefore true for all n greater than or equal to 1. And that's all. So you do need a wee statement at the end. We normally number them actually 1 and 2, but I haven't in this case, but 1 and 2 is normally what we write down at the end.